Automatic transmission pressure control. Flow from the oil pump enters the pressure regulator valve and applies pressure against the spring. When the force on the valve overcomes the spring force, the valve moves to the right, which opens the exhaust port. This releases some of the pressure back to the oil pan. This causes the pressure to drop slightly. When this happens, the spring can close off the exhaust passageway. This repetitive process is used to regulate line pressure. Adding pressure to the boost valve compresses the spring, which makes it more difficult for the valve to open the exhaust port. This causes the line pressure to increase. Modern transmissions all use pressure control solenoids to control the position of the boost valve. The solenoid is controlled by a control module. The control module uses an on-off technique called a duty cycle to control the position of the pintle, which ultimately controls the flow of fluid through the solenoid. Pressure control solenoids are often called PC solenoids, line pressure solenoids, or EPC solenoids, which stands for electronic pressure control. To test the pressure control solenoid, information from the repair manual will be needed. I will need the wiring diagram and the location and connector information for the transmission control module, or TCM. After logging into all data and entering the vehicle information, click on Diagrams. Choose the electrical OE and then choose Automatic Transmission and Transaxle, followed by Automatic Transmission Wiring Diagrams. The pressure control solenoid is labeled AT-LPSV. That stands for Automatic Transmission Line Pressure Solenoid Valve. Select this option and then click the image to zoom in and zoom out. Zoom in on the transmission control module and note there are two PL duty cycle connectors. Pin 2, wire color brown and yellow, has a DR next to the name. D stands for drive and R stands for reverse. This indicates that this pin is used when the transmission is in drive or reverse. Also note the use of the drop resistor. This is used to limit the current through the solenoid so it does not overheat. Pin 2 is where we're going to make our diagnostic tests. Additionally, note the TCM reference number M77. Scroll to the bottom and note the image of M77 over here on the left. Also note the W under the ID number. That W means that the connector color is white. The image also has numbers in the wire cavities so that you can find them. Pin 2 is the connector we want to test. Now we're going to locate the control module. Click on Relays and Modules. Then scroll down and find the Automatic Transmission Relay and Module, and then click on Control Module. Now under Locations, click on Components. Click on the image to zoom in. Here we find the Transmission Control Module listed right here, and the line indicates that it's down here on the left side of the dash. Click the X to close the diagram. Now scroll down to the second diagram and open that image. Here we have a better look at the location of the transmission control module and the two connectors that are used to connect it to the system. Click the X to close this image. Now it's time to move to the vehicle, locate the control module, and connect up to pin 2 to perform the functional tests. Pressure control solenoid duty cycle testing. I have located the control module under the left side of the dash and I have unbolted it for easy access. I identified the module by the two connectors, one white and one gray. On the white connector, I have identified the brown and yellow wire that is in pin 2. The next step is to back probe the brown and yellow wire with the back probe pin. Connect the digital multimeter black lead to a good metal chassis ground and the red lead to the back probe pin that is in pin 2. Turn the digital multimeter on and set it to DC volts and choose the percent option to measure duty cycle. The trigger should be set to negative. With the engine running, set the parking brake. Place your foot on the brake pedal and press down hard. Shift into drive and fluctuate up and down on the gas pedal with your other foot. This should trigger the computer to adjust the duty cycle to accommodate for a simulated load from fluctuating the gas pedal while in drive. Observe the meter during the gas pedal fluctuation. A duty cycle response indicates that the computer is responding to the additional load. This is the expected response. The next test will be with the Picoscope. Connect the Picoscope leads to the back probe pin and ground the other lead. Additionally, zero and connect the amp probe around the brown and yellow wire from pin 2. Connect the voltage probe to channel A and the amp probe to channel B. Set the scope to record. With the engine running, set the parking brake, place your foot on the brake pedal and press down hard, shift into drive and fluctuate up and down on the gas pedal with your other foot. Now place the vehicle in park, stop the scope recording and analyze the pattern and show it to your instructor. Down here we can see that I saved this file for this Nissan, and up here we can see the red channel is in amps, so that's going to be my amp probe, and here the A channel is your voltage, so that's my voltage probe. What we're looking at is we're looking at this area on voltage, and you can see the change that's happening. This is the duty cycle change that's happening as we're accelerating. And if we look at the red line, which is your amperage, you will see that when the voltage is at 0, the amperage is also at 0 over here. When your voltage goes up, your amperage is also going up. And this duty cycle that's taking place is showing us the amount of time we're dutying it is actually controlling how much time this amperage stays at 0. And the 0 amperage is going to be an increase in line pressure. And we can also see how this duty cycle is impacting this little blip right there on the amperage scale. So I've moved the amp channel up a little bit so that we can see the relationship in the voltage and the amperage change right at that point right there. But I've also done something else, is I've added a negative duty cycle measurement value here. So we're currently measuring the whole trace right here at 73.86%. However, if I choose between the rulers, we will notice that I have drawn a ruler that lines up with this edge right here, and another ruler that lines up with that edge right there. And that has given us an 80% duty cycle for that particular range. If I move my rulers over to something that has a little bit larger difference here, we can now see that our duty cycle has considerably changed down to 48%. And that's because we're getting different values here compared to over to here.